Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 2 from the October-November 2023 Cambridge 9709 Statistics S1 paper. This is paper 5, variant 2. And this question here, we're told about George has a fair 5-sided spinner with sides labeled 1, 2, 3, 4, and 5. He spins the spinner and notes the number on the side on which the spinner lands. Find the probability that it takes fewer than 7 spins for George to obtain a 5. So here we have an example of, again, discrete random variables. Okay, but this is a special kind of case of one. Here, basically, you have something where you've got to find the probability that it takes fewer than 7 spins for George to obtain a 5. So the person spins the spinner, okay, and either it lands on a 5 or it doesn't. So the probability of it landing on a 5 is basically, as you can see, there's 5 out of 5 choices, just one of them, so it's 1/5, which you can say is 0.2, okay, and the probability that it doesn't land on a 5, I'll call that 5 complement, is going to be 1 minus 0.2, which is 0.8. Okay, so in this case, this is a type of probability, or this is a type of discrete random variable, which is called a geometric one. So we can say that the random variable x, which is, the number of times it lands on a certain, or the number of times it's spun before it lands on a certain spinner. So x is the number of times it's spun. So the random variable here would be the number of spins required, okay, before it lands. We can say until it lands on a 5. Number of spins until it lands on a 5. Let me learn how to spell properly here. Until it lands on a 5. That's what x is. Okay, so this is a special type of a random variable which is called geometric, because in this case you have a probability of that is, again, the discrete values, okay, and the numerical values, discrete random variable. It's random. You don't know when it's going to land on a 5. It could be on the first or second or third or fourth. We don't know what it is. And also, there's a set probability of success or failure. In this case, success is landing on a 5, which we're going to call P, which is 0.2. And failure is landing on not a 5, which is 0.8. So P here means success and Q means failure. So what we do is here we put the probability of success here, 0.2. Okay, so this is how you set up a geometric distribution. Okay, this is the notation for it. So the random variable is such that it's geometrically distributed with a probability of success 0.2. Success here meaning it lands on a 5. So here we got to find that the probability that x is less than 7. Okay, that the number of spins required is less than 7. Which would mean we got to find the probability of x being equal to 1 plus x equals 2 plus x equals 3 plus all the way to the probability that x is equal to 6. Because this is the same as saying the probability that x is less than or equal to 6. Because here we have discrete random variables, so there's nothing between 7 and 6. So if it's less than 7, there's nothing. When you start from less than 7, the first number you're going to get to is 6. So it's less than or equal to 6. So that's what this basically means. This is the same thing as this. All right. So we need to find the probability of all of these and add them together, which is a bit of a tiresome thing to do. Now, in the formula sheet, there is a formula also for geometric sequences, which I have got over here for you. Okay, so here we have formula for geometric sequences, And one of the formulas that we have, as I said, for the geometric distribution, the probability of a particular, number of, throws or spins, whatever, is the probability of success, okay, times the probability of failure to the power of r minus 1. Okay, so basically, probability of success is once, and the probability of failure is all the times before that. So basically, what it means is, for it to land on a 1, okay, on the first spin, you're just going to have basically 0.2. For it to land on the second spin on a 5, it means the first spin has to be not 5. So you have not 5 and then 5. If it's on the third spin, you're going to have 2 times not 5 and then 5. So basically what this means is you have 1 minus p r minus 1. That's q, basically the failure. You're going to have the failure to the power of n to the power of 1 less than the number of throws times the success. So for us to do this properly, in this particular way, which I'm not going to actually do, but I'll just show you how to start it. It's going to be basically the probability that lands on a 1 would be basically just the probability of success, okay, which would be 0.2. Plus, here you'd have the probability of failure first and then success. And here you'd have probability of failure twice and then success. All right, and then all the way to, you do the same thing. It would be 0.8 cubed times 0.2. 0.8 to the power 4 times 0.2. 0.8 to the power 5 times 0.2. And then you add them all together. And you get the answer. And that's perfectly fine. If you can think about doing it in this way, that's fine. And you'll get the answer, but it'll be a bit longer. Now, there is a formula which is not given in the formula sheet, but I'm going to show you from what I have in my notes here. Okay, now this is something which, in this type of question, it's not something we can really prove that easily just in this particular setting, but it's something which is, something that we should know, that the probability of x being less than or equal to a certain value, which is 6, is going to be 1 minus the probability of failure, which is 0.8, to the power of that number of times. So this will give us, okay, the same answer as adding all of those separate probabilities together. Okay, so first of all, you've got to understand when it says the probability of x is less than 7, we can say less than or equal to 6 because they're discrete random variables. So between 7 and 6 is nothing. It's just 6 or 7 or 8 and so on. Okay, that's one thing. And so that's what we have to understand here. Now what we can do is we can just work out what this is. Okay, the probability that x is less than 6 is 1 minus the probability of the failure to the power of r. Now this is not given in the formula sheet. So this is something you have to memorize, this and also this one, which will come useful in the next part of the question. But those are things that you need to memorize. Okay, they're not given in the formula sheet. What's given in the formula sheet is simply is this formula here, and the fact that the mean value is 1 over the probability of success, which we don't need in this part of the question. So here what we're going to do is we're simply going to put this in a calculator. 1 minus 0.8 to the power of 6. That gives us 0.737856. 737,856. So we can say the probability that x is less than 7 is equal to 0.738 to 3SF. And there's the answer to part A of this question. Okay, so this is a geometric sequence, okay, that we needed to deal with. Now we're going to go on to the next part of the question. We might need these, so I'm going to take these down here. So in the next part of the question here, we're told that George spins the spinner 10 times. Find the probability that it obtains a 5 more than 4 times, but fewer than 8 times. So now we've changed, it's not a geometric sequence. It doesn't say he spins the spinner until he lands on a certain thing. Here there's a fixed number of spins. Now when there's a fixed number of spins, then this is a binomial distribution. this is a random variable such that it's a binomial distribution. And here n stands for the number of spins, which is 10. And p stands for the probability of success, which is 0.2. Remember, p was 0.2 and q was 0.8, right? Obtaining a 5, probability of getting a 5 is 0.2. The probability of getting not 5 is 1 minus that. So this is now a binomial distribution, and the formula for binomial distribution is slightly different here. And we want to find the probability that it obtains it, that x is more than 4 but less than 8. So x is greater than 4 but less than 8, which is the same thing as saying the probability, as we discussed earlier, is between 5 and 7. Okay, between 5 and 7. Now, for us to do this, I think the easiest thing for us to do is to find the probability that x is equal to 5 plus the probability that x is equal to 6 plus the probability that x is equal to 7. That's probably the easiest way to do this question. Okay, and for binomial distributions, this is the formula over here, that the probability of a particular number, that it lands on the 5th row, okay, the probability it lands on the spinner on the 5 times, okay, is going to be more than 4 times and less than 8 times. Yeah. So here, x, the random variable here in this particular case is the number of times the spinner lands on the 5 in the 10th rows. So the random variable is different here. Okay, so lands on a 5. Okay, so the difference between these two, here, the random variable is the number of spins required for it to land on a 5. Okay, and here the random variable is the number of times the spinner lands on the 5. Okay, the number of times in 10 throws, how many times it lands on a 5. So there's a difference between the two random variables here if you think about it. So this means the number of spins required, all right, until it lands on a 5. Okay, and here it means the number of times the spinner lands on a 5 out of those 10 throws. All right, and this is the formula that we need for the binomial distribution for each individual one. So here we're going to find the probability that it lands on a 5. Now we're going to have, this is NCR, this is like the combinations button. So NCR, N is the number of throws. So you have 10C5, and you have P, which is the success. So 0.8 to the power of 5 times the failure, which is Q, to the power of 5, because they have to add up to 10. It's kind of like binomial expansion. And then we're going to have, for 6, you're going to have 10C6, and you're going to have 0.8 to the power of 6, and, sorry, let me just write that again. You have success, which is 0.2 to the power of 5, and 0.8 also to the power of 5. Here we're going to have 0.2 to the power of 6 times 0.8 to the power of 4. We'll have to add up to 10. Okay, so add up to 10 always. Plus, and the last one will be 10C7, 0.2 to the power of 7 times 0.8 to the power of 3. That will give us our answer that we're looking for. And you can just put that in a calculator. So we know, hopefully, how to use this button. 10C5, we use the NCR button, which is this one here. So you have 10, shift, and you press this. That's 10C5 times 0.2 to the power of 5 times 0, whoops, be careful there, times 0.8 to the power of 5 as well. Okay, plus, again, be careful, plus, and you're going to have 10C6 times 0.2 to the power of 6 times 0.8 to the power of 4. And then you're going to have plus 10C7 times 0.2 to the power of 7 times 0.8 to the power of 3. that gives you 0.03271. 0.03271 goes on. So therefore we can say the probability that x is greater than 4 and less than 8 is equal to 0.0327. And there's the answer to question part B. And that concludes this question here. So this one, the first type of random variable was a geometric type, for which you use the geometric formula. And the second type was what's called a binomial distribution. Okay, so the two different types of discrete random variables. So the whole of this paper so far, question 1 was like a normal distribution, was like a discrete random variable question. Okay, just a general one. And part 2, question 2, you have a geometric and a binomial distribution type of question. Okay, so they're all to do with discrete random variables, all under the topic of discrete random variables. Okay, so that concludes this question. Other questions from this particular paper can be found in the playlist that will appear over here. And other questions from the topic of distributions, like discrete random variables in general, I'll put that over here. And you can subscribe to my channel by clicking on this link. And other questions, or if you want to see my other material, this video will show you how to find it. Thank you for watching, and see you soon.